Partial fraction. To integration of partial fractions, what we're going to have to do is when you're getting something complex like this to integrate, what we're going to have to do is to separate it as the integral of the sum of the two partial fractions. This is known as integration by partial fraction. So what we're going to have to do is we're going to have to rewrite this as something like the integral of, now this part that says x squared minus 2 over x plus 1, we're going to have to break that up. Right here we have x squared minus 2, left to right, x squared minus 2, and we know that in partial fraction it would be ax plus b over x minus 2 plus the integral of, break this up as partial fraction, it would be a over, or maybe another constant, c over x plus 1. So before we can do integration by partial fractions, we're going to be able to know how to break up this thing right here into partial fraction itself. All right, so that is what we're going to look at now. We're going to look at how to break this up into partial fraction. All right, so that's what we're going to do. We're going to be looking at how to break this up into partial fraction. So we're going to go to partial fractions first, and then we come back to integration of partial fractions. Great. But before we can integrate it, we need to be able to can separate this into partial fraction. Now you might ask me, what is this partial fraction? Now let's go over what is partial fraction. Let's go back to primary school. Let's go back to primary school. In primary school, we'd have learned stuff like 1 over 5 plus 1 over 3. And we would have been saying 1 over 5 plus 1 over 3. To add them, we'll find what is known as the LCM. And the LCM would be 15. And so it's 5 into 15 3 times plus 3 into 15 5 times. And so we get 8 over 15. Right? Now this would be the sum of these two partial fractions. All right. Now, what if I had given you 8 over 15 now? Let's say I'd given you 8 over 15 and I ask you to separate it as the sum of two partial fractions. To do that for me, you would have to say, well, I know that it would be a over 5. It would be some number over 5 plus some number b over 3. And then we'd have to work out that a is 1 and b is 1. All right, that's what we'd have to do. We'd have to work it out such that we'd have 15, then that would be 3a plus 5b. And then we'd have to say which two numbers a and b satisfies to give us that 3a plus 3b is 8. The only possible number that we can see right there is that what? Be a equal 1 and b equal 1. Because if a equal 1, we get now 1 over 5 plus 1 over 3. Now, of course, we could have had different numbers, like let's say when a is negative 1. When a is negative 1, then what b would be. Right? So we're seeing that some different partial fractions we could get from this is that 8 over 15 is equal to, when a is 1 and b is 1, we get 1 over 5 plus 1 over 3. That's one possibility. Right? We're seeing that 8 over 15 is 1 over 5 plus 1 over 3. But another possibility would be what happens if a is negative 1. If a is negative 1, then what we have is negative 3, bring over the negative 3, bring over the negative 3, bring over the negative 3 to get, that's not working. Then let's try negative 2. Negative 2, that's not working, because negative 6, bring over the negative 6, that's positive 14. So this looks like the only feasible option that's going to give us a fraction. Right, so this is now known as partial fraction. It can be given this now to separate back into two fractions, whereas in primary school you were given the two fractions to add and you use LCM. All right, so that's all is partial fractions. We're going to break up one fraction into two or more fractions. So let's go back here now. There are some rules to do partial fractions, and these are the rules in doing partial fractions. For CAPE Unit 2, there are two types of fractions known as proper fractions and improper. So just like in primary school, improper was like 5 over 7, 5 over 4, 7 over 4, 3 over 2, 9 over 2. Those are improper when the numerator is greater than the denominator. Now, in terms of CAPE Unit 2, whenever the power of x in the numerator is equal to or greater than that of the denominator, then it's an improper. For example, 7 over 3, 2x squared plus 5x plus 4, x squared minus x minus 5, 5x cubed minus 3x squared plus 1 over 3x squared plus 7. These are all improper because the power in the numerator is greater than or equal to that of the denominator. To do improper fraction, we're going to convert from improper to a mixed number. And now the types of proper fractions are type 1, when you have two linear factors, it's just a over the first linear plus b over the second linear. Type 2 is when you have a quadratic that cannot be reduced. It's ax plus b over this quadratic plus c over this linear. Then you have p of x over this. Then it's just going to be a over ax plus b over ax plus b all squared plus c over cx plus d. And then type 4 is when you have a quadratic that cannot be reduced and it's repeated. All right, so those are the four types of partial fraction that you will come across. Very easy stuff. Easy, easy, easy. So right here the question says expressing partial fraction. So we're going to express this in partial fraction. To express this in partial fraction, it's very simple, straightforward. Now this is which one of them? X squared minus 2. X squared minus 2 cannot be factorized or simplified, and so it is type 2. It's type 2. When it's type 2, it is ax plus b over this plus c over the linear one. So it's going to be ax plus b over x squared minus 2. It's going to be equal to, since it cannot be factorized, it is ax plus b, ax plus b over x squared minus 2 plus c over x plus 1. And now all we're going to do is solve for a, b, and c. So to solve for a, b, and c, what we're going to do is find the LCM on this side, and the LCM is just going to be x squared minus 2 times x plus 1. This is LCM, x squared minus 2 times x plus 1. That's not a z, that's a 2. This is a 2 times x plus 1. So then what we're going to do now is do our regular division. So we're going to say x squared minus 2 into this goes x plus 1. And so we get ax plus b, ax plus b times x plus 1 ax plus b times x plus 1 times, now x plus 1 into this goes x squared minus 2. So we get plus c times x squared minus 2. C times x squared minus 2 is cx squared minus 2c. Minus 2c. Alright, so cx squared minus 2c. Now look at this now. Remember initially the question was that this is what? 3x squared minus 4. 3x squared minus 4. And it's being divided by this same denominator. So we can just draw the line continuous. So now since the denominator is the same, what we do is we equate the numerators. So what we're then saying is that 3x squared minus 4, that is equal to this over here. It's equal to this over here. All right, it's equal to all of this. So we can do is expand it, and we can just expand it by saying ax times x is ax squared plus ax times 1 is ax plus bx. So we're getting ax plus bx plus b, ax plus bx plus b, ax plus bx plus b plus cx squared minus 2c plus cx squared minus 2c. Now, in order for the left-hand side to be equal to the right-hand side, then what we can do is equate the coefficients. So we're going to equate the coefficients of x squared. We're going to equate the coefficient of x. We're going to equate the coefficient of the constant. So the coefficient of x squared is 3, and we have a ax squared and a cx squared. So what we're saying then is 3 is equal to a plus c. That's what we're saying. 3 is equal to a plus c. 3 is equal to a plus c. That's all we're saying. 3 is a plus c. Now once you add these, now what's the next thing? Now you need to equate your coefficient of x. Equating your coefficient of x, you notice we have a 0x. We have ax plus bx right there. So what we're saying is 0 is equal to, that looks like a plus b. 0 is equal to a plus b. Smooth and nice so far. Now since 0 is equal to a plus b, then what we have right here now is negative 4 is our constant. Equating the constants, we have negative 4 is equal to negative 4 is equal to, equating the constants, we have b and we have minus 2c. So negative 4 is b minus 2c. Now look how we're going to easily solve this question now. Now from the second equation, it would make sense to make a the subject, right? From the second equation, we can see that a is equal to negative b, a is negative b. And so if a is equal to negative b from the second equation, I can plug a as negative b in the first equation to get 3 is actually negative b plus c. If I plug a as negative b in the first equation, I get 3 is negative b plus c. Then I can add these two equations. If I were to add them, I would get that minus 4 plus 3 is minus 1, and minus 1 is equal to b plus minus b, that gone, minus 2c plus c, that's minus c, and so what that is telling me then is c equals 1. C is equal to 1. If C is equal to 1, I can put 1 here, and what plus 1 give me 3, that looks like 2. So I'm saying that A is equal to 2. A is equal to 2. If A is equal to 2, then what is B? B is negative 2. Then B is going to be negative 2. So now look, we have finished this question. So we can go back up to here now and say as a partial fraction, this is going to be ax. This is going to be ax plus b, and I can erase what is right here. This is now ax plus b. A is 2x plus b. This is now minus 2. This is now 2x. B is minus 2. And c is 1. So good. So all of this right up here can be separated as 2x minus 2 plus 1 over x plus 1. This is it as a partial fraction. Very, very easy. Soft.